Additive manufacturing is such an exciting field to be in right now because it affects almost every single industry in some way, and it's exciting to be at the forefront of that. So I work with our sales engineers to make sure we configure our products for our customers to meet their application needs.
At Dortmund University, we have our research unit where we are investigating dental implants made of titanium. They are permanent. And in the second phase, we move to magnesium implants, which are biodegradable. Traditional implants made of titanium are manufactured by conventional technologies, for example, milling and turning. With additive manufacturing, we have the possibility to create new geometries, for example, lattice structures, where we can exactly adapt the stiffness of the implant. So my dream really is that in 10 years we have the possibility to produce patient individual implants, which really have good reliabilities.
We have the capabilities of doing additive manufacturing in-house, so from the design through the additive manufacturing of these designs up to the mechanical characterization using the ElectroPuls machines allows us to speed up the research.
The ElectroPuls systems are very important. They are very capable. We also equip them with specific accessories, with specific chamber systems to realize boundary conditions which are very similar to the human body, for example. We have exactly this testing setup, which works perfectly.
Additive manufacturing has many factors that influence the reliability of the final product. So you don't want to add another influence factor with the testing machine. So the testing machine should guarantee that it produces always the same results at any place.
Patient-specific implants. This is a very hot topic, I would say. At TU Dortmund we have the E1000, the E3000, E10000 and E20000.
So Instron machines are very accurate and reliable. And one big advantage is that we can test without oil. We do not have any type of contamination, which is very important when we are testing implants.
It's all about reproducibility for us. Due to the properties or characteristics of durability and variability, we are able to achieve reproducible results, which are very important for us. I really enjoy working with Instron machines because of the good support, a very good accuracy of the machines, a variability, so I am able to make some changes in the methods, make some adaptation of new ideas for the research, and always with a strong collaboration with the Instron.
It's important for our machines to be easy to use because the students are constantly changing, and when the new students come in, they need to be able to use the machines as quickly as possible.
I started with 2 technician assistants, and now we have around 25 PhD students and 10 technical staff members and trainees and 20 student assistants. That means we are now a big team and working together, and everybody is important to reach the goal.
I met Professor Walter and his team in 2010 when this department was founded. Over the time they grew rapidly, and it was great to be a partner along that way. I think that the most important thing on this partnership is the trust we built over the last 15 years. The fact that this partnership lasts so long is the proof that it works for both sides.
At Instron, we see more and more inquiries for customers who want to use additive manufacturing for functional parts across various industries.
It's automotive industry, it's aerospace industry, and it's biomedicine. In all of these 3 areas, additive manufacturing is very important.
With 80 years of experience of material testing equipment and thousands of machines installed worldwide, we are confident that we have the right solution for additive manufacturing testing.